In section 1.8, we have a few more terms that we need to define first. A term, remember, is a group of variables and numbers that are combined using only multiplication or division. So our terms in this expression would be 12x squared y, because that's a 12 multiplied by an x multiplied by another x, that's what the square means, multiplied by a y. We also have the term negative xy squared. You'll notice that that negative sign does need to go with the term, because that x is getting, this term is getting subtracted from the other terms, so we don't want to lose that negative sign. The positive signs, just like not having to have go signs at an intersection, we don't have to keep. So that's just going to be a 7x for that term. A negative 3/4 y, and our final term is a constant, 20. Coefficients, remember, are the number parts that are on the fronts of terms. Anytime you have a term that doesn't have a number part, we insert the coefficient 1, the multiplicative identity. Because remember back to the identity rule, multiplying something by 1 doesn't change its identity. So if we put a 1 in between that negative and the x, multiplying by negative 1 times x times y squared would give us the same thing. So our coefficients in this group are going to be a 12, a negative 1, a 7, a negative 3/4, and a 20. The next thing that we need to look at is the idea of like terms and unlike terms, and what makes something like and what makes something unlike. Like terms are terms that have the same variable parts. So notice that it only says that the variable parts need to match. So if both of the terms have an x, their numbers, 3x, 2x, can be different. Unlike terms have different variable parts. So as usual, it's easier to understand these if we do some examples. So for problem 10, we're going to separate this list of terms into like terms. So our first term that we have here is just an x by itself. So I'm going to start a row for x's right there. Negative 7 is a constant. It doesn't have any variables with it. So we'll make a column for the constants right there. X squared is not the same as an x, because remember, x squared means x times x. So this term has 2 x's in it, whereas this one only had 1. So x squared is going to start another column for us. Negative 1/2 can go on the list with the negative 7, because it's also a constant. 3x can go on the list with x, because the variable parts are both an x only. Because if you'll recall, this variable's coefficient is actually 1. We haven't seen any terms yet with y, so 3y squared is going to start another column. And negative 1/2 y, since this y is squared and this y is not, is also going to have to go in its own row. Now the negative 7y squared can go in the same column with the positive 3y squared, because only the variable parts have to match, not the coefficients. Negative 1/2 x will bring us back over here to our x terms. Negative 7y will go here with the y terms, and negative 7x squared will go into this column with the other x terms. So that's how we group like terms. Now let's talk about how those terms can be combined. Some people like to think of this as using the distributive property in reverse. So if you remember, the distributive property said if you have a number on the outside that's being multiplied by two different numbers on the inside, you can distribute it to each one. If you look at our example here, you can see that both the 13 and the 4 have had a b distributed onto them. So we can just back that out by pulling the b out front and taking the 13 minus 4 off of it. See that? The b undistributed itself, went the other direction. And 13 minus 4 leaves us with 9. But usually in algebra, we write the coefficient in front of the variable. So 9b would probably be our final answer for that. If you like writing them out like this, undistributing the like terms before combining, it's fine to do that at this stage. But if you'd rather, you can just look for terms that have the same variable parts and combine them together without using the reverse distributive property. Do make sure that the sign in front goes with the term. So just like a stop sign happens before the intersection, that negative is happening before that 8. It belongs to the 8. That positive belongs to the 5D, and that negative belongs to the 1. So when we go to look for our like terms here, we have a positive 1D right there, and 5 more D's right here. So that gives us a total of 6 D's. And then for our constants, we have a negative 8 and a negative 1. Well, negative 8 take away another 1 is going to leave us with a total of negative 9. This one might be easier to do using the reverse distributive property since we have to deal with fractions. So I'm going to take the 7/10 minus 1/3 out here in front and leave the y squared outside while I solve this problem. My lowest common denominator here will be a 30, so I can change to equivalent fractions by multiplying the first fraction by 3/3 and the second fraction by 10/10. Please make sure you're continuing to carry your y squared sign down with you as you solve this problem. So 21, take away a 10, would leave me with 11/30. And now that I've combined those two terms, I can remove the parentheses.